Okay. Welcome to the second session of the workshop. And the topic here would be digital marketplaces. We will have 3 talks. Each one will have 4 minutes. And, maybe just a few words. 3 projects for the marketplaces. DOM 4.0, Marketplace, and VIMMP. The last 2, they were on the same call. DOM 4.0 was a bit later on a separate call. And DOM and Marketplace, they are still running. And the first one would be by Amit.
Yeah. Thank you so much. Hi, everyone. I'll need coffee for this one. I must admit, I think it was Joanna who put the template together for the talk. And I found, personal disclaimer, I found it extremely hard to answer some of the questions. So Joanna, if that was the plan, you did it really nicely. And I'll get to why it was hard to answer some of the questions and the justification for that. But I think it's a brilliant template for starting and engaging in terms of discussions, because some questions I found there was no right or wrong answer. I was also a bit skeptical, and I must say personally scared, because Laszlo, who is monitoring our project, is here. Plus now, to add to that, Bjorn is also here, who is also project monitoring officer for DOM. So I think some of the answers, they may not want to see them, but I've still sort of dared to put them in. And over the coffee break, I was just discussing with Bjorn the dilemma between a Gantt chart, which is the project management perspective on running and managing a project, and the software architecture / software running of sites in an agile way, which basically means there are lots of recirculation loops, which you cannot necessarily put them sort of openly at the start of the project. You can't envisage them. You can't put them in a linear fashion. So there's this struggle between the PM side and the TM side, i.e. the technical implementation, continuous improvement, continuous delivery, CI/CD versus the traditional Gantt chart. So with all those disclaimers, I think now I feel safe to start the presentation. I'm going to use the slide advancer for this. Okay, maybe not.
Yes.
Okay, yeah. We need some hardware interoperability. Thanks, Joanna. Yes, thank you. So, okay, let's get started. So I'll be presenting on behalf of the DOM team, and some of the contributors and partners are here in the audience. So I might also request them to pitch in, especially for some tough questions and discussion later. So let's get started. Just a quick recap for those who weren't in the session 1. What's DOM about? It's a digital open marketplace ecosystem. The focus is on the word ecosystem because we want to connect semantically and syntactically with other marketplaces, OSPs, open simulation platforms, translation environments, knowledge bases, etc. It's a multi-partner initiative, and it's a multi-sided ecosystem with data providers, consumers, and the digital service providers. As I mentioned this morning, it's not just about delivering the 9 showcases, or we call them showcases, in the project or in the proposal. So I'm sticking with that keyword. Not just delivering the 9 showcases, which are in themselves cross-sectoral. They have data sharing involved, but also as part of the sustainability and exploitation beyond the project, we want to identify what are the linkages between the showcases so that we can use the common framework developed in Dome to then expand the scope of Dome. Two quick examples, and I'll touch on these. One is the collaboration with Market 4.0. This was done with Dome using connectors, and I'll get into the details of that. And then we figured out, okay, this is on the manufacturing side as Market 4.0 looks at production equipment for materials. How do we connect that with the materials side? And that's where the EPFL's materials cloud comes into the fore. So Dome now connects and communicates with both Materials Cloud and Market 4.0. So there was directly a showcase of showcases, which covers number 5 and 6. And recently, while delivering the first showcase, which is CMCL showcase that covers maritime, environmental, and nanoparticles for air quality and port cities, we also identified some linkages and commonalities across data sources between Showcase 1 and the Materials Cloud Showcase, in particular to look at pollutants and their characteristics in more detail, and so on and so forth. So these 9+2 showcases are proceeding as planned, and we will continue to identify links and connections to exploit the project further. What we have tried to do differently is to come up with a minimum viable prototype. This is on the DigitalOcean cloud, as was envisaged at the start of the project, but the intention is to have it as a multi-cloud environment or even an on-premise deployment. It's a very simple MVP at the moment with certain features that I'll talk about briefly. The plan is at this point, I don't know if that's what you had in mind in terms of the organizers, but the plan is to show some demonstration or examples and then go back to the question and answer slides as well. So I have used the template, and the proof of that is, for example, here, but it might look that I've not prepared it fully, but I've left literally the template as is and tried to answer as many questions as we can. Sometimes the questions are not relevant to Dome, not by design or anything, just because we are not engaging in the work related to the question, and sometimes where I found it impossible to answer it, I've said it so, and that's open for discussion. So with the slides there in mind, let's take a break. Let's move to the question and answers, and then again, so we'll need to go through that in sort of incremental steps. So the questions here, so taking a pause here and saying the question in the template was what were, are the main challenges in the ontology development pipeline? And the 4 points to consider here in Dome, given just the amount of work that's needed to push the 9 showcases and the MVP platform, we have taken a practitioner's approach and an agile software methodology within Dome. This was right from day one of the project. The ontologies have been used in 2 areas. One is for the ecosystem itself, and I'll again in the next few slides give you a few examples of that, and to adopt standards such as, or standards and practices such as the DCAT, which is the data catalog, MSM, so service model, Euroscience vocabulary, EMMO, EVMPO, etc. The ontologies reuse has been demonstrated in the project in certain showcases, and I'll give you examples of those. With regards to communication between domain experts and ontology developers, this was fortunately, given the size of the team within Dome and the expertise, this was very much feasible, and that again happened from day one. A big shout out to OntoCommons for that, because we did rely through a dedicated work package 5 led by Evgeny. we were able to communicate with OntoCommons in parallel. So that communication has been clearly leveraged in the project. Then there was an interesting question on how did you overcome these challenges? I don't think I've answered this in a perfect way, but literally the agile way we adopted this was to release something, even imperfect, but to release something out there in the public domain, to break things, to learn, and to improve the demonstrator in sort of series of cycles. And it was a nightmare, I must admit, to do this in parallel with sort of tracking it on the Gantt chart. But I think midway in the project, so after 2 years, we have now got the hang of it. So we would continue with this methodology. Then the question on if you use the published ontology development strategy, we are aware of the phenomenal work that's been going on in OntoCommons with regards to LOT, and I must say we haven't adopted that fully yet. The current work done is together with OntoCommons, and Emanuela will talk about this in the next session, which is the DCAT semantic enrichment. So we looked at vocabularies, DCAT, DTherms, RDFs, and performed the semantic enrichment work and mapping with EMMO, which was done in close cooperation with OntoCommons. And I think I've covered that. So yeah, so that's the answer to the question. Then one more slide with Q&A. How much value do the ontologies currently bring to your system? That's I would like to put quantitative values, but currently the answer is very qualitative midway through the project. The one is in terms of potentially bringing value. One is linking decentralized data sources, software, and enabling interoperability. This is a clear winner. The impact of that is shown through the showcases and or the B2B showcases that we have. So I'll cover that point in the next few slides. But I also feel for our showcase as an SME, as CMCL, the adopting the ontologies was absolutely critical because we are looking at smart city ports, and for smart port cities, we couldn't have done the job in terms of connecting the smart infrastructure with the energy application side, with the environment, with maritime, without ontologies. So it just wouldn't have been feasible. So there's a clear value there for our end customer, which is a port authority. Can your system cope well with ontology updates? I would say short answer is no, not yet. And I've said this is because we are not there yet. And this is a very important aspect. I completely understand why this question has been raised. If we were to talk about an individual showcase level, yes, we can do that now. But if we need to talk about the DOME as a system level TRL, as a system in itself, then we are not there yet. This requires quite a lot of resource in terms of testing and development. Yeah, and we didn't write it in the proposal, but I shouldn't have said that. How does your system handle missing ontology terms? Yeah, I must ashamedly say that it's through user intervention, i.e. human intervention, and it's done manually currently. If that's the best approach or not, I don't know, but that's again open for discussion. Okay. Yeah, I should be able to cover that. Some of the slides are not to go into in depth, but to just show and demonstrate to back up what I was saying on the slide. So number one, this is to show the work together with OntoCommons, and this is what you see here is the mapping between DCATs and DC terms with the concepts that you see in the EMMO ontology. Again, Emmanuel will go through that in detail. Talking about the ecosystem ontology itself, there is merit in reusing and learning from things that have been done in the past. So EMMO, Euroscience vocabulary, DCATs, minimal service model, EVMPO, etc. And we have come up with a conceptual, basically a draft ontology for the ecosystem itself, which again covers, the classes would cover things that are familiar with a marketplace ecosystem, such as a platform with a product catalog, then a product resource, what you want to do with data as an asset, i.e. view, transform. Right. Okay. And the HTTP method, for example, to do with connect, get, post, and put. It's not just on the technical side, but also the business side. You can see that the ontology for the ecosystem considers the offering, the value it brings, the monetization, etc. And just to show on the right that there is a mapping between the concepts space or the class space between DOM and EMMO. Then going back to questions, do you consider FAIR principles? We are starting to do that, and this is about 6-month-old work. So we are learning more and more about FAIR, about fairness tools. Then in terms of in what way your ontologies promote FAIR principles, I must admit this is not done uniformly across the DOM ecosystem and the showcases, but it's been done in quite different or varying levels of digital maturity across the 9 showcases. For example, in showcase 1, we have been able to identify all the 4 elements of F, A, I, and R to our satisfaction using ontologies, but that's not the case for every showcase. Okay, we strongly believe and want to demonstrate that ontologies are the prime drivers for promoting all 4 aspects of fairness. This is one example of our learning. For example, just to show through open data that this is materials characteristics data in JSON format with a very poor fairness score versus the ship emissions data and maritime emissions air quality data in RDF format. And you can see that the fairness improves from 4 to 18. This is just a quick assessment based on the Fuji tool. Again, with different tool sets, you can get different answers as well. So can you tell us about your experience in integrating your data sets? So yes, on the ecosystem level, concepts based on reuse of DCAT, MSM, Euroscience VOC, and on showcase level, the ontologies and agents, again, used in showcase 1. These are not necessarily we have discovered them or we have developed them from scratch. These have been already published. All the ontologies used are published in the on GitHub. Lastly, can you demonstrate how the developed ontologies are used for data sharing? Yes, because the 3 examples are through the IDS connector and Optimade. So DOM with Market 4.0, DOM with IDA Lab. This is for data and simulation of molecular characteristics. And finally, the showcase 1 for the cross maritime air quality for Smart Port City. That's our showcase 1. And just to demonstrate how that is, so the data prosumers can, for example, search a material using Optimade and then also get corresponding machines that could be used as from the product catalog from Market 4.0 using semantic search. That's how it works with the 3 aspects. One is the DOM ecosystem, Market 4.0, and the IDS framework. IDS is also connected with DOM because they are on our external industrial advisory board. That's the example with IDA Lab, and that's the example with the Smart Port City case. And I think this is the last slide. Do you use offer connect to any form of data space? And with access rights. So access rights are currently under development and review. We're using the Hyperledger blockchain for that. And again, going back and forth on how to develop it further. How useful is the platform outside of the consortium? It's a bold question. After 2 years, I can say not very useful outside the consortium yet. But what we learned in the hackathon 1, which was a few months back, we had very good response. And for the next hackathon, we are planning a live onboarding session because people have expressed interest in joining Dome. Do you have a sustainability concept? Yes, but on a showcase level to start with, because that's more digestible for us. Not yet on the ecosystem level. Again, happy to go into details of this. This is just a snapshot from the hackathon, again, to just support the answers. It was a fantastic event, but I want to skip that. Thought that was the, okay. One concept that works well, I think MVP of the platform, one major challenge, still working out how best to deploy resources for implementations versus improvements. And this is going back to that agile thing that I started with. The example is whether we continue with a very clunky Hyperledger blockchain, which ticks all the boxes in the proposal, or do we move to a simplistic database logging solution using a conventional database with an ontology mapping on top? But these are the questions. Last 5 lessons, I think agile versus waterfall has its pros and cons. MVP with minimum features, we found it to be important than waiting for the perfect solution. Semantic enrichment based on reuse of existing standards and existing ontologies developed, such as EMMO and DCAT vocabulary. Multiple B2B showcases. These are at varied semantic maturity levels. And there has been work done in the literature on how do you assess the digital maturity for semantic showcases. So we are delving into that. And lastly, substantial resource required for the technical development related to B2B showcases. And can we really expand the scope by connecting multiple showcases, which would improve Dome's exploitation. So, and I've covered all these, so thank you indeed for your time.
Please gather your questions, and we will have some opportunity at the end. Next speaker is Dirk, which we already met, discussing the marketplace, which I'm also working in.
Thank you very much. And so coming back to the marketplace project, the marketplace is a materials modeling marketplace to increase industrial innovation. We are 18 partners working on this project for 5.5 years. So we are in the last months of the project, and the research partners are distributed over Europe. They are universities, research institutes, SMEs, and larger industries involved in the project. And let me start with a short introduction motivation, but you already see this slide. So it's materials modeling and simulation. And that is the reason why we are addressing with this marketplace in our focus the needs for modeling and simulation to optimize materials, materials design processes, process design, components design, and product design. And this user perspective I already show was some starting point to analyze what are the requirements from the market and tailor the system in this direction. So what is a marketplace? So we use this term, could be confusing. So that's the reason why I underline what is the goal of this marketplace. And in the morning, I make many items about different things, what I would like to have. So my wish list on a marketplace. And this was also the starting point of this marketplace project to develop a one-stop shop for materials modeling and simulation. And what we have here on the, we have also a cursor. Maybe not. Yeah, maybe difficult to handle. Yes. And then maybe we can. So it's a laser pointers. Everybody can see it. Fine. So we have three important pillars here. So one is the explore, the other is the interact, and the create and execute. You remember on the other picture I showed this morning, these are exactly these points. We would like to be able to search data and knowledge, like, for example, materials relations or material models for representing the material behavior. Also about available software products. We would have access to benchmark and validation data to test our materials relations, for example. On the other hand, we need the opportunity to interact. We would like to interact not only with the system, we would like to interact also with the community. And so there are possibilities planned like training, education, discussion and user feedback, and the translation service. And the translation service, for example, is one opportunity where you as an SME can go to the platform, fill out a questionnaire, and get suggestions for possible translators and to support you in the solution of your simulation challenge. The create and execute, that is one important pillar, because we would like also to make some kind of operations on the data and tools on the platform. So we have an app store in the platform. There's a workflow manager. Existing open simulation platforms like AIDA are incorporated, and in the background there's also a connection via Kafka to an HPC server. And else, all this is our vision, our plan for the materials modeling marketplace. There's also some global search capabilities that you can search different kind of data, and maybe you can imagine in the back end of such kind of a very abstract view, there must be a lot of technology be developed to have such a system running. So what are the key technologies in the background? So we use ontologies in different aspects like platform management for the software and workflow communications, for the interoperability to enable a seamless communication between different kind of applications. The platform has some kind of variability. This means you can register as a user, you can define user roles, register apps, and so on. And also, for example, the discussion part of the platform, you can add content. And there's the platform environment itself, where it's a web-based platform. There are different APIs defined in this setup, like the marketplace API for some kind of communications, and also the HPC service is, for example, connected. So coming to the topic ontology, we'll also focus on these ontological aspects of the marketplace today. And in the marketplace, we have some integrated services, not all, but some, which are based on ontologies. This is, for example, the ontology-based knowledge service, what is some of the core of the platform, and also the model relation database where we develop an ontology. And these services are based on ontologies, and different ontologies are developed, like, for example, an expert ontology, a software ontology, a material ontology. Partially, these ontologies are based on EMO, but you must keep in mind during the development. So we start also in the core development phase of EMO. So there's also many things developed in line with EMO, but not directly connected. And we already see this European Virtual Marketplace ontology. This was a joint cooperation of VIMMP and Marketplace to enable some kind of connection between the platforms. Let us have a look on the knowledge service as one possibility where we use ontologies. On the platform, we have the possibility to log in. Then you can create something, you can create knowledge items. And these knowledge items could be an organization, could be an expert, could be in software, and many different things. And for example, first we register in software. For example, here's the software Micros. It's a phase field simulation engine. We can make simulation and modeling with this software. And this we register first. In a later step, we are able also to refine the software and add some ontological terms to the software. What is the key feature of the software? So some knowledge of the software is then there. On the other hand, we can register also an expert. And then again, we do the same step as before, and we can select over a menu some characteristic competences of the expert. So for example, here, expert in continuum materials with multi-phase materials, for solid materials, and so on, going deep to the ontology. And what is then one possibility? And this possibility is you can then explore the information. And if you look to Google, for example, try to find an expert who is an expert in phase field, has the competences to use the software, and maybe is willing to be a translator or some supporter. It's more or less not possible without time-consuming extra connections. And in such kind of an ontological system, we are able to connect it. So you can make a search looking for some terms and find the connection between the software and the expert who is be able to orchestrate the software and support you. The interoperability is the second very important part inside the platform. Here we have the requirement that we must connect different kind of software tools via the platform and via APIs and let them speak together. In the marketplace, we realize also the question, should we use ontologies everywhere, or should we maybe tailor it to the needs? And for example, to lower a barrier, it's for example also useful to enable or allow that a software tool could be registered on the marketplace without an ontology. That is maybe the level 0, some simple link. Then maybe using the marketplace API is maybe the second level. And what is here level 1? And level 2 is the semantic integration of the software tools where we then use the ontologies. And this is then used in the software integration of the App Store. And as mentioned already, we have a different kind of APIs developed for orchestrating these software tools and the data exchange on the platform. Let us look to one use case as an example. So we have 6 demonstrating use cases on the marketplace platform. And the use case 1 is a use case about additive manufacturing, a very important new manufacturing capability in industry. And we are focusing here on superalloys. And in this use case, we orchestrate 2 simulation engines. On the one hand, in particle code, who is be able to make a complex physical simulation of the melt pool, so the melting of the particles. And on the other hand, in phase field engines, so the micros, to represent the microstructure evolution during solidification. And what we are doing here in Sympathics, the complex laser-based additive manufacturing process is simulated, and the key information we exchange is a temperature field. This is then transformed to the Micros app to calculate the microstructure evolution. And in the background, it happens what you see here. So we use a semantic mapping in this case. So we have the level 2 integration. We're using D-Lite containers and MO entities. And what happens here from the integrated open simulation platform AIDA, we orchestrate the start of Sympathics. Sympathics gives the data back. The data are then transferred with the next operation to Micros, and Micros gives the results back. And this operates on a semantic level, semantic integration of these 2 software tools. One important keyword also in the slides we get from the Onto Commons Consortium is the term data documentation. And here at this point, I would like to make advertisement for the MODA, the modeling and data. That is a quite powerful tool we learn also in the marketplace to document the simulation workflows. On the one hand, we can generate some kind of a graph. On the other hand, we have some very detailed information about the modeling and simulation issues. And I, as an expert in this field, I must say, if I see the MODA for this process, I must say that it's totally complete. I have a very detailed overview what happens, what's ongoing in this kind of simulation. Summary and experience. I also answer the questions, or we answer the questions, and I try to bring it in a little bit other shape. So ontology development challenges. So there are challenges reaching, for example, a cross-discipline acceptance. In the consortium, we have physics, we have engineers, material scientists. They do not speak from nature the same language, so they must also be synchronized. There's a large variety, so you can connect any kind of application to the marketplace. So a large variety of domain ontologies is at the end required for the level 2 integration, for example. There's some challenge to dealing with missing concepts in ontology. At the time where we start with ontology development, there was no established collaboration environment for ontology development. That's a very big point. And yeah, the use of ontologies to interact with other platforms, what you also see for DOM 4.0, is a quite important topic with still existing challenges. Added value. From my perspective as an engineer, if I'm be able to find a connection between experts, software, models, materials, then it's for me an added value. There's a real benefit of the ontologies. On the other hand, we learned also in the marketplace that is partially a very high barrier to use the ontologies, and we go some simplified ways. For the data exchange, communication between two simulation tools, it's of course still a big benefit to use ontologies. Standards. We try to use the EMO and the latest release of EMO. That was quite helpful to have this framework. The ontologies are used for some examples, and partially we use taxonomies to keep it simple and to make the right progress in an agile development cycle. Ontology update and extension, that's also a challenging topic. So we are modifying the T-box, have some connecting data in the A-box, and there are some ways needed how we can update ontology, maintain ontologies, and so on. So there are still some unresolved challenges there. Our ontologies are partially stored at the end according to FAIR principles on a GitHub. You can use these ontologies. It's integrated partially in the EMO GitHub. On the other hand, we also have an own GitLab for the project, and some ontologies are stored there. At least for the consortium, findable, accessible, interoperable, reusable, but not for the whole world. The relation to data spaces, so the marketplace, so materials modeling marketplace is focusing on the modeling simulation. So there's no deep data space integrated. We have up to now also no deep connection to a data space, but it's at the end natural that something like this is needed. What we have in the systems, there are classical databases inside to store benchmark data, validation data, and we use for the communications also data sync and data source applications. Platform access, at the moment not possible. Some legal issues. We finalize at the moment the terms and conditions. So hopefully the platform is soon available for everybody. And for the sustainability, we are discussing as a consortium to found an association to make the marketplace project sustainable also after the end of the project. Support by funding bodies. The overall support is already great. So there was a very excellent communication with the Commission to further develop the marketplace. Maybe two things, what could be needed. Legal aspects are quite challenging. Terms and conditions going online with digital platforms could be great as there's a central support to this, because we have at the end the repeated questions. And if you talk about sustainability, to my knowledge, or maybe I haven't found any program where maybe persons who are interested to make a company from 3 countries in Europe can make a program and find a program to collaborate together, something like national programs which are available. But maybe I have not the complete knowledge about these paths. So the last thing, concept that works on the platform, knowledge app is from my perspective, from our perspective, a success story. So it's a good way how we can use the ontologies. On the other hand, if you will represent everything with ontologies, then it's quite a high effort. And lessons learned, using REST APIs, defining minimal viable products, what you also heard before, it's quite good. The ontologies are not really needed for interoperability. That is also the reason why we have these different levels for orchestrating the applications, for example. And supporting different levels of integration is good. So the maturity models, Then some lightweight apps, that's maybe the other topic. So we have very complex use cases in the project. And what we also learned, and we also realized it's in use case 6 at the end, that we connect only a single app to have an added value by this single app and the data exchange possible via the marketplace. And yeah, some software licenses and other legal issues. So going with the commercial software on the platform, have some billing service and so on in the right way. That's also some challenging topic where we also learn some lessons. So hopefully see you soon on the marketplace platform. Try it out in the future by your own. And I would like to thank you very much for your attention.
Thank you. The last speaker for today, Silvia, will be presenting the VIMMP project.
So I'm in an even worse situation than Andrea before because it's before lunch and should find the slides. Thank you. Thank you.
And then you can.
And to.
I think it's already. Can you see it? Yes.
And to switch slides, can I use the arrows?
I think this.
Yeah. Okay.
Yeah.
Thank you. So hello everybody. I'm Silvia from UKRI, in Research and Innovation. And today I will tell you some lessons learned. Maybe we can remove, sorry, this. Can we remove this without killing the session? Yeah. I will tell you some lessons learned from the VIMMP project. Sorry. The VIMMP project, that was the sister project of the marketplace we just heard about. But what I will try to do is to do, very briefly, to tell you about the project and its semantic side. But of course, time is very short, and to answer also some of the questions that are relevant for this. So the project was involved many partners, and here you see representatives of 4 institutions that had a major role on this facet. So it's UKRI, it's ourselves. We were in charge of this standardization and semantics. Then GCL supported us on this very strongly. Ostus was the platform architect, and IFAM was the project coordinator. And my colleagues, Martin and Gerard, they are in the audience, so they can also add to this. So briefly, VIMMP stands for Virtual Materials Marketplace and was a project that finished last June. And it developed a platform to facilitate exchanges between providers and users. So you see examples in this slide in the area of materials modeling. So typical providers will be software owners or translators or modeling experts, and typical users will be industry researchers or research managers. And the typical goods would be training material, again, software, data, and workflows, and so on. And the base of interoperability between components is a set of semantic standards, a set of ontologies. So the VIMMP ontologies, here you see a scheme of this system of ontologies. And the development was led by Martin, who is here in the audience. And every bubble represents one module that deals with the concept. So for example, we have OTRAS for training and topics. Then we have MMTO for materials modeling translation. OSMO, that is the MODA ontologized version of MODA for models and simulations, and so on. And arrows mean that one module connects to the other. Then we have, beside these 8 domain level ontologies, we have middle level modules that connect them to the top level, that is the EMMO. And at that time, so we started in 2018, so at that time EMMO was also being developed. So in the meantime, it has changed, has been renamed, and the logo has changed. So we follow this process. So the license of the ontologies is GPL version 3. They are available on GitLab repository where the development happens, and there are a series of documentation papers and so on, and there is a slide on this. How are they used within the platform? So they are used for the metadata. And so for data ingest and storage, search, and for browsing in the data space. So this is about, so you see here this bubble AVMPO and in the middle level. You heard about this already in the previous two talks. So what is it, just to give you an idea, is the European Virtual Marketplace Ontology. So this was a joint effort between VIMMP, Marketplace, and the MMCCSA. And it's a middle level ontology to help interoperability between the different platforms. So the idea is to have there all the categories that are needed in a typical virtual digital marketplace. So here you see the top categories, and there are also others, but I mean the main 11 ones are listed here. I won't go into details, but for example, you have concept like infrastructure that is needed. And the idea is that this would support the simultaneous query across different platforms if everybody follows the same vocabulary. So here you see an example, a snapshot of the VIMMP platform. So you see that the categories you have at the top, so you have challenges, computational resources, datasets, people, software, and training. They reflect the bubbles I showed before. And I will take some example software. So you see here, we are not logged in. So as a public user, we run a search for DL star. We find two softwares, and one is DL Polyfor. And you see the typical entries. So in this case, you are seeing a metadata only record, and the concepts that are used on the left, and also, the drop downs on the right, they come from the ontologies VISO and OSMO, that are two of the modules you saw before. So this is an example, as I said, for software, but besides software, there are the other categories. So for example, in people, you would have experts, as we saw before in the talk by Dirk. And I don't know, in training, you would find the training resources and so on. And challenges, what we call challenge, would be like a way to pose a problem to the community, and then the community could answer with a proposal and so on. And yeah, sorry, I forgot to mention that this is based on a piece of software that is called Zontal Space. And so the user interface and the APIs and the Zontal Space component were run by Ostus, the platform architect. So these snapshots you see, they come from this software. Maybe I can also add that you can see there are filters. So for example, you can search by software tool type. So there are also some categories, again, coming from the ontologies that I used to filter out in the searches. So you have simulation engines. You can't see the full, but it's simulation engines, post-processing, and so on, similar to what Dirk had before. This is another view of when you are ingesting information. This is how you would see the fields to be filled in. And the drop-downs that appear on the right, they are also coming from the ontologies. And in turn, they come from knowledge sources like ROM. So for example, the physics equation type that you see on the right, they come from ROM, and so on. So again, what the fields and the drop-downs come from the ontologies. And I should say that the drop-downs are generated by Sparkle queries on the ontologies. Even more technical, so where the exact connection is done internally. So you can see here that there is, this is a view from the backend. So you have the connection to the ontologies is done via the URIs. So both the properties and the classes, they are connected directly to the URIs of the terms in the ontology. And something else I can add is that when you are in the backend, you can also see information like the definition that also comes from the ontology. So each term has its definition and other properties. Again, this is a view of Zontal Space. So then I answer some of the questions. So which tools have you been using? So we use, for the development, we use Protégé. OntoFox we use to extract pieces of ontologies. Then we use Already2, it's a Python tool, so we use it for automatizing certain class creations and so on. And for data and then metadata management, we use Zontal Space, as I said. For documentation, we use Vidoco for some components, and then Matportal and GitLab. So we have the VIMP ontologies are on Matportal and they are on GitLab. Which ontologies we use? So, of course, CMMO, that is a top-level ontology for applied sciences, EVMPO, you heard about this already. And then the VIMP ontologies, and then we reuse many semantic artifacts. I mean, both generic, like SCOS, and more specific, like the software ontology, SWO, and many others. But I'm not listing them, but you can see them in the documentation. And what benefits did you observe? I would say the main one is better knowledge organization and metadata handling across the whole platform. So aspects of fairness, access, and governance in the data space. So I'm summarizing here. So when it comes to interoperability, there are many levels. So if we think both of syntactic and semantic interoperability within the project and with the wider space. So what on the semantic side, we use ontologies in all, this is standard language, and Turtle format, that is also standard. Then coming to within data exchange component, we use RESTful APIs. They were available for ingest search and download, and they exchange data as JSON LD, that is also standardized format for linked data. And at the level of interoperability with the community, so we reuse multiple artifacts, as I mentioned already, and also we formalize knowledge sources that were not formal, like MODA and ROM, so we included concepts from them into Osmo and other ontologies. We aligned with the MMO and co-developed a VMPO, as you heard many times already, with Marketplace, and is also being used within DOM 4.0. On the data space side, so if we think of data space in the data spaces support center sense, yes, we had a data space with the user interface and APIs. And in the data space, the entries could be just metadata only. You could also have attached files. And then there were, if you think from the UI level, there were different access levels to the records. So you saw before a view of public, a public record, so open to all. Then there are restricted entries that are only visible after login. And then there was the possibility, we called it a collaborative space. There was a possibility to create private spaces between given users to exchange, for example, files and to chat. And about the question, how does the system deal with ontology updates? So what we had was a workflow for metadata governance was designed. So this is available. It's called the taxonomy editor as a deliverable from the project. So where we thought of the workflow, what happens when the metadata change, how this impacts, whether this needs to be reflected on the platform, how does it affect the third parties and so on. Of course, it's not simple to put it in practice, but it was there. Challenges and difficulties. So here is a summary of what we think is relevant in this context. Something happened with font size, I think. So I think using, new technologies, but without missing out on existing technologies and tools is difficult because you risk to miss out on all the expertise and also all the software stack that is around. And you might have your workflows in place, so it's not easy to change everything. And as already Hedy mentioned before, with this balance between rigor and being useful, it's difficult to find the balance between expressivity and usability. And related to this, it's difficult to identify a suitable level of detail for descriptions. So to know when it is, where is the right bar. And on time constraints, so you need to make many choices when you're developing ontologies, and it's very hard to combine consensus within the community with the development time constraints. So that is also complex. And finally, of course, we reuse many assets and it's very valuable, but it's also hard to find and evaluate how suitable they are. So it's, and then you also need to harmonize them. So this is another difficulty. Coming to the lessons learned and suggestions. So as I said many times, semantics is an important part of the solution of interoperability, but I mean, there is also syntactics, and normally there are constraints that come from the technical implementations. So the hint would be try to understand those as soon as possible, so that you are aware, I mean, of the constraints you have in your system. And then the human factor. So as you saw, the drop downs and so on, these user-facing components, they need to be navigable and friendly. So lots of thought had to go into those, because I mean, it needs to be readable and needs to make sense, and needs to be, I mean, of a length that makes sense and so on. So there is also this UI aspect to it. And then, very importantly, annotation is very time-consuming and is error-prone. So the annotation of your data, you need to think who will do it. It would be good to have it automated as much as possible, but also tools can fail. But so, yeah, you need to keep in mind who will do the annotation and also the alignment. And then it's important to share your own ontologies also in the early development stages, because otherwise, I mean, it's too late to get any useful feedback. And it's important to get feedback from peers, from end users, from developers of the components that will use the ontologies, and so on. And then, as OntoCommons emphasizes a lot, it's important to do an in-depth documentation of the assets, including the alignments. And I think with this, the references. So, as I mentioned, there are a series of papers, but I think, I'll just leave you with this, and thank you for your attention. And I would like to thank, I mean, all the colleagues. I think I wasn't as brief as I thought. Thank you very much.
All right. We are a bit late with the schedule, but nevertheless, is there anyone who would like to make a comment or ask a question? Please. Maybe the microphone should be activated.